explain what the Holy Father is. Okay, well, I've explained this on a couple other things, on a couple other videos, but technically it's the boson-Einstein condensate. And this is how it goes. Alright, so the Big Bang Theory, it's got holes in it, okay? You know how, like I explained on another one, I poked the holes in the fact that space always exists, okay? You can't remove emptiness, okay? You can't remove nothingness. It's already nothingness, but it's still something because it's an area for potential, for something to happen, okay? So you have an area there. That area has to always exist. You cannot remove that area because an area is an area. That's space. You cannot remove space. Anyway, the only way to remove space is by adding matter, okay? They say the Big Bang created space, time, and matter all at once. Well, you can't create space, especially by adding matter, okay? You got to remove space, or matter to make space. Anyway, all right, the perspective of space. Okay, look. Okay, say you have no Big Bang Theory. Throw it out. Just go with the laws of thermodynamics. Okay, energy can't be destroyed. It just always is. It only transforms from one state to another, highs and lows. It's always about highs, mediums, and lows, technically. But it's always just, it's space and energy. That's all that there is, was, and always will be. Okay, the alpha and omega. Alpha, nuclear energy. That's the Y factor. That's male energy on every scale, even on the bio scale, on the human scale, animal scale, whatever. There's nuclear energy, bionuclear energy, okay? Nuclear energy in space, quantum energy, it's in matter, it's in everything, okay? The electric energy, it's the same thing. It's a female, it's an egg. So you have the seed, which is the male, that's the Y factor. That's always the nuclear energy, the nucleus. Even in cells, you know, zygote, you know, atoms, stars, it's all the same, okay? You always got to understand that alpha and omega really is real. But it's technically alpha, beta, omega. That's what creates the universe. Alpha, beta, omega. Literally. And if anyone wants to ask, what's alpha, beta, omega? Okay, well, you have your nuclear energy. Okay, that's the Y factor. Alright? Okay, that's the Y factor. That's the nuclear energy. Okay, the beta is the decay. Okay, because this nuclear carries the male and female, just like we have in nature. Okay, that means that the man carries the X and Y chromosomes. Okay, and then obviously the X and Y, everybody knows that in math, algebra, and all that. That's part of this science that literally is that we've separated. It's all in individual. We got them all in individual fields. Well, it's not all individual fields. It's all the same field, okay? And I've managed to connect them all through this. And if you really believe in me, I can show you some stuff, all right? But look, alpha, beta, omega, okay? This is what creates the universe. Obviously, it's going to have to do with energy and quantum physics, okay? Alpha, beta, and omega is that. Okay, because this is when the Y, the nuclear, decays into the electric, which is the omega. Okay, that's your female. So you have your Y and your X. This is the Y factor. Ironically, Y factor and X factor, X-Men. You know, it's amazing how Marvel connects to all this. I think they went and visited the Vatican and got some info. So did George Lucas and Walt Disney. And plus all their connections with aliens. Literally, I predicted about 20 years ago, well, about 15 to 18 years ago, that these three companies would literally join just through the connections that I found with the Baltic Sea anomaly and the fact that with Werner von Braun and Disney, you know, the Millennium Falcon looking just like the Baltic Sea anomaly. It was amazing, you know. There was just a lot of stuff that indicated that it literally told me this. I mean, literally. I mean, I've predicted a lot of stuff with this theory, man. Because this, I mean, I've been on it for years, but only 3 years ago I actually figured out the alpha, beta, omega part, which pretty much solved everything. Alright, so you only have these with space. Alright? Okay, now the Higgs boson, I'm going to go ahead and just cut to the singularity. I'll show you how it formed here in just a little bit, but I'm just going to cut to it and get I'm going to show you a perspective here. It's like a fifth dimensional thinking in a way, because you're imagining that you are space. And literally think everything is in you, you know? And you have to kind of look at it like that. Like you are space and you are infinite compared to this matter. You know, whenever the relativity comes in and when I have to make a correlation. But anyway, all right. Okay, say you have the singularity. All right, now the Higgs boson, they say, oh, we found the Higgs boson. All right, there's people that say, no, they haven't found the Higgs boson. All right, because the Higgs boson's heavy. All right, and that's right. Okay, the one they found, the particle they found that they think is the Higgs, is too light to be the Higgs boson, alright? The Higgs boson is extremely dense. You know why? You know why it's massive? Because it's the singularity. It's literally what gave birth and mass to everything. Duh. All right, I'm not trying to be an ass. I'm just saying, duh. All right. So anyway, now, if this, they say, all right, well, the Higgs boson's going to have a spin. Okay, this is going to have a spin, but relative to space, it's not going to have a spin because space is literally looking at it from all angles all at the same time. You see what I'm saying? So it literally does not see it spin. Okay, look. Say you have a rope, all right, and you're tied to this, okay? And it's spinning really fast, and you're looking straight at this. You're not going to see it spin. Even if you look back here at space, you're only going to see black. You're not even going to see any spin back here. See what I'm saying? Even though it's spinning relative to an infinite factor like this, it doesn't have a spin because literally it's like looking around it all at the same time. Imagine an eyeball wrapped all the way around the singularity, okay? And if you put yourself right here relative to it, you are right here at a point relative to it. So whenever it spins, boom, it's going to face you again. It's going to spin again, and it's going to spin again. It's going to face you. It's going to end up facing you. It's going to end up facing you every time because you are relative right here to it. See what I'm saying? But space is all around it all at the same time. So it's not going to have a relative spin to it. Until you can jump in here and monitor it and start looking at it, now you are in there relative to it, so now it has a spin. But if you jump out, that universe technically only existed as long as you was in there to measure it. Because there's no time. And you are the matter relative to time. Alright? So, basically, you can't have time without matter. Because matter plus space equals time. And that's basically how it goes. That's no joke. Alright. So that's a perspective of space. Imagine you are space and you're looking at this thing from every angle all at the same time. You're not going to see it spin. It's going to just look solid stationary to you. It's just going to sit, you know, until there's something in relative to it. All right, and another thing with the Big Bang, well, what was it relative to if it was so tiny? Well, infinite space. I mean, that's what it was relative to if it was tiny. You can't even have a size unless you have something else relative to it. Because size is a relativity. They're going to say it's tiny. And plus, it needed an area to exist in anyway. And plus, the energy had to exist prior to create it. All right, which I'm about to get to. All right, so it's basically a macroneutron star. Okay, it's like a macroneutron star. Now, space is a 1 and a 0. Okay, it's 1 and 0. It's neutral because it's something and it's nothing. Okay, it's a flat area. Or, I mean, it's a three-dimensional. It's a multi-dimensional area. Infinite dimensional, to be quite honest. But it's an area, basically, that is neutral. Okay? And this is one reason the asymmetry comes in. Because the reason why the asymmetry is, it's more geared toward a regular matter. Okay? Once you have this Big Bang, you have an ether and a CMB, which is light and sound. All right? They don't even consider the ether. Okay? But it exists. It has to. It's light. We exist in the light. No matter what. That's the neutrinos. That's the fabric of the space that we see. The neutrinos, like that's everywhere all the time. I mean, it's like the fabric of the light. You know, it's the ether. It's analogous to the CMB because light and sound are, I mean, they're kind of like matter and time are. You know, when you have one, you have the other. You know, they're just. But I'm digressing. Alright. Anyway. Now, when you zoom out, you have literally everything that's big becoming small. I mean, you zoom out forever. Alright. Then you can zoom in. Alright. These zoom in and zoom out is a relative factor to the microcosm or the macrocosm. Okay. Now, on the microcosm, okay, now you're going to have quarks. Now remember, quarks are self-born. Okay, they're self-born. The only thing in the universe is self-born are quarks. Okay, and they pop in and out of existence. These are the point particles, like Heisenberg energy, 0-point energy. Okay, space does this, creates quarks. These are micronova. See, relative on its factor. See, we don't use a scalar relativity, and the problem is they need to apply a scalar relativity. The closest thing they have is scale invariance. And that's where the problems are at, where the theory of the large meets the theory of the small. The quantum theory meets the theory of relativity, you know? They're fundamentally incompatible. But it's not that they're incompatible, it's the fact that they don't have the scale invariance figured out. Okay? they know numbers, but they're not looking at it as a scale. They're looking at it as just a bunch of digits. They're not looking at it as a scale. Okay? It's its own regime, its own universe. It has its own relative time. Even though this micronova, this point particle, lasted just a split second, when you zoom in on its cosm, on its relative factor, it literally lasted a stellar lifetime. You know, just like any other star. But it's just on a microcosm, things happen a lot faster. Even though it's its own relative time. See what I'm saying? It has a scale of relativity. There's the microcosm. That's what these were. The far ancients knew this stuff. But anyway, I'm going to digress again. All right, so these are micronova. All right, these are high energy quarks, which are converting into low energy quarks. Okay, which are basically like a star converting into a bunch of gas and matter and stuff when it blows up, creating more planets and stuff. That's basically what's going on here. This is creating planetary material, which is going to be low energy quarks. And I got a theory here about these. Okay, so they say, you know, I mean, obviously 2 up quarks and a down quark is a proton. Okay, well technically you're not getting protons in that yet. These have no color charge, so technically you might not even have up and down quarks. Now, what I suspect is a smaller cosm. I call them preons and zyons. Now they know preons are part. They theorize they're a part of a quark. Okay, and I've added zyons because it just makes sense, or zetons, you know, with the zeta. But preons and zyons, like 2 preons and 1 zetton equals an up quark, and 2 zyons and 1 preon equal a down quark, and then 2 up quarks and a down quark equal a proton, and then 2 down quarks and an up quark equal a neutron, you know, and so on and so forth. Well, technically that's the end, and then matter and molecule stuff. But anyway, so this is low energy, okay, quark material. It has no color charge yet, so there's no up and down quarks, but it's going to form into a real dense neutral star, which is like a preon star. Okay, it's going to be a preon star on its way to a neutron star. Now what it's doing, as these quarks all form into a preon star, they're starting to gain color charge, okay, which is going to make them into neutral quarks. Because remember, space is trying to re-neutralize, okay, it's trying to revert back into a neutral state, which is 1 and 0, all right? Once the first micronova happens, it's chaos theory. Space basically tries to re-neutralize itself. So what it tries to do is it does what it does to try to equal itself out. And while it does this, it creates a universe. And as the universe reduces, it's still neutralizing itself out. It's reverting. This is reversion. Okay? It's reverting back into carbon, basically. Carbon predates the singularity, technically. And I could prove this. This can be theorized and probably proven because hydrogen, helium, and lithium, you add those together, you can get carbon. And if you reduce carbon, you can break them down into hydrogen, helium, and lithium. Okay, so they're interchangeable, basically. But anyway, this preon star is really dense, okay? Very dense. And as it cools, it's going to expand. Just like how a normal star would start dying, or, you know, becoming a red giant and such, you know, the singularity does the same stuff. And we can even prove this. We got all these theories, and inflation, and, you know, and expansion, and blah, 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 all the, you know, we got all the theories, but it's like, why aren't they putting it all together? You know, I just wonder, why don't they put this stuff together? It's so easy. I mean, I'm not trying to be a cocky. I'm just, I don't know. It's so easy. I mean, it seems so damn easy. God. Anyway, all right, so before you have this thing getting into the preon state where it's getting hot, okay, this up and down quark, this right here is literally going to be the nuclear energy. This is a whole. Space is a whole, okay? And this is the nuclear energy, which is alpha. And alpha means father, okay? So this is the Holy Father. Okay, before it heats up, it's not going to be hot yet. You're literally going to have the boson-Einstein condensate right here. You're going to have basically like holy super atoms, more or less, until it gets hot, which is going to be quark gluon plasma. What we think we made, oh God, we invented quark gluon plasma. No, we didn't. We basically rediscovered it. This is how the universe formed. It was quark gluon plasma first, you know. But anyway, I'm gonna get ahead of myself. All right. So you have the Bose-Einstein condensate here, which is really the Holy Father. And the Holy Father is smoke-like, literally. It's like a smoke material of nuclear energy, smoke, nuclear energy floating around. Hence, holy smokes. I thought that the other day. I thought it was funny. I figured maybe this might be somewhere holy smoke really came from, because it's insane how well it fits. Insane. And it's all the holy. Every time we say holy something, it always matches with holy being space. And the Father, Holy Father, is the alpha, the nuclear energy. Hence, alpha meaning father, and alpha male. You know what I'm saying? The Y factor. This is literally the nuclear, the male energy of the universe. Okay, and it's going to beta decay into female also. Okay, but it's not. It doesn't do that yet. All right, not yet. Okay, so this is the Bose-Einstein condensate right now. It's pretty much like it's low energy quarks. It's what's going to be the nuclei of an atom, but it has no color charge. It's like sub-zero temperatures. It's literally almost exactly zero. It's not at the state where it's hot yet. It's at the cold state right now. Okay, I don't see how. Anyway, all right. So right now it's in its cold state and it wants to get hot. So it's went from a high energy quark to low energy quark. And this low energy quark wants to go back into high energy. And it's going to end up going through the singularity, yada, 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 and then going back into low energy, which is matter. See what I'm saying? There's configurations of energy, too, actually. I probably should pull that out here in a second. But, all right, anyway. Okay, so this Bose-Einstein condensate literally will come together and form a preon star. All of this holy smoke is going to coalesce like anything else would, okay? Because gravity still exists. And on a micro scale. There's a microverse there. It's like gravitons. Gravitons are real. We just can't detect them because it's hard to detect our own gravity. More or less, we just know what it is and, how to measure it. We can't actually detect what it is. It's basically it's just a warping of space, yeah. But it does this on a small scale. Even though we can't measure the scale that it's doing it, space recognizes everything that happens inside it. It knows. It recognizes everything, and it can put it together. It just puts it together. Like gravity just knows what to do, Gravity does it. But anyway, or whatever you want to say. So, this is going to end up getting hot. It's going to become like a preon star, which is going to end up becoming, it's going to gain color charge. So now it's going to want to form neutrons, okay? Up and down quarks. And these up and down quarks are going to literally want to form neutrons because it wants to remain neutral now. Now it's went from a high energy, low energy, high energy, and it's at a neutral state. And it's going to beta decay into, instead of, all right, now I'm going to put this on the bioscale too because this mimics our biological nature in a zygote. Okay, now, when a zygote's fertilized and it goes through its replication and interface, it will produce 2 daughter cells, okay? And then it'll go through its interface again. It keeps doing this, and 2 more daughter cells, 2 more daughter cells, okay? This is exactly what the singularity is going to do. Instead of daughter cells, it's going to release an electron and a proton, because neutrons are going to beta decay into those 2 particles, because a neutron is neutral. It's -1 and +1, which is neutral, and it's going to want to produce protons and electrons. So it's going to beta decay. It's basically going to be a giant neutron that's going to beta decay, and as it does this, there's going to be a plasma of electrical energy and nuclear energy, protons, neutrons, and electrons floating around here. It's going to expand as it does this. And it's going to get bigger. It's going to inflate. And all these protons, neutrons, electrons from what was the Bose-Einstein condensate has heated up into it like a preon star, which became a really super dense quark gluon plasma, which became a neutron star, which became a plasma star, which is now expanding and going to grow into a living universe. So whenever this gets to the point where it's going to go into its big bang or cosmic fart, because on our scale, we are like, this is probably like our sun compared to, it's going to be way bigger than that. But just as a relative factor here, okay? This thing, when it blows up, it's going to be like, a big bang. But to space, it's only going to be like a cosmic fart, literally. It's just going to be like how a nebula would be born, But that's what it creates, a galactic nebula, You see what I'm saying? Instead of like a crab nebula, like a star's going to die, on a larger scale, our singularity does the same thing and creates a galactic nebula, which is a universe, you know? All right, anyway, so it's going to pretty much do the daughter cells now. When it's born, it's going to throw the cells out, which is protons, neutrons, and electrons. All right, now, protons and neutrons will stick together because a proton and a proton can't stick together, but they'll repel each other. So the neutrons have to hold them together. But, that, of course, we know that. The thing is, also, this electron wants to kill that proton. All right? But since the neutron is a species of both of them, of nuclear that decayed into both of them, it helps the proton and the electron get along. So instead of it killing the proton, it'll go into orbit. It's like, oh, well, all right, I won't kill you, so I'll go into orbit, you know? So this helps atoms form. And the simplest atoms are going to form, which is basically going to be atomic hydrogen, you know? They're going to be gigantic, pure hydrogen stars. And as they die, the generations of matter start, you know, the hydrogen, helium, and lithium, you know, start forming and yada, yada, yada. We know all this. But the thing is, they have all the stuff to prove everything before that. I mean, I don't know why they don't. I mean, I know this happens. I don't care what anyone says. I know this happens. I know it. I know my physics, man. I really do. And not to mention, literally, religions help explain this in a way too. But people aren't listening. And like I said, the Holy Father, they're taking stuff into other regimes of ignorance. The non-believers are taking it to ignorant regimes, and then the believers are taking it to ignorant regimes. You know, they've taken it both into two. It was right here, and one took it this direction, one took it way this direction, and now the truth is like somewhere in the middle, lost. And I'm just trying to help people find it. So, you know, it tells us this stuff. Like religions say, like the factor here, hermaphroditic. This nuclear alpha is hermaphroditic because it decays into the female also, the male and the female. It carries both. And neutron means neuter of protos, you know. And, you know, with the